Welcome to The Explainer. Today, we're tackling something pretty huge, laying out the ultimate blueprint for the Internet of Things. We hear IoT thrown around as a buzzword constantly, right? Well, today, we're going to transform that abstract idea into a concrete, layered architecture that you can actually visualize, build, and understand. Let's get into it. Here's a quick roadmap of where we're headed. We're going to define the IoT ecosystem, look at the 5 pillars of connection, build out the master architecture, explore some paradigms from the everyday to the extreme, and finally, weigh the potential against the friction.
All right, part 1, defining the IoT ecosystem, from one single fridge to literally billions of devices. To wrap our heads around a massive global system, we really have to start small. Let's look at a totally everyday example, your fridge. It uses built-in sensors to detect when you're out of milk, hops onto your home's Wi-Fi, and automatically places a grocery order for you without you lifting a finger. It's an entire ecosystem built on a surprisingly simple equation: a physical object plus sensors and software plus internet connectivity.
But here's the thing. The absolute most crucial part of this definition of an autonomous network is right at the very end, without human intervention. When we talk about these networks, we mean the object itself, whether it's your smart fridge or a giant robotic arm in a factory, becomes its own independent, smart agent. It's quietly collecting data and acting on it entirely in the background while you go about your day.
And here is why you should really care about this. We aren't just talking about a handful of smart gadgets for tech enthusiasts anymore. We are hurtling toward a jaw-dropping 22 billion connected devices by the year 2025. Just think about that. That's nearly 3 smart devices for every single person on the planet.
We're looking at an unprecedented exponential expansion, jumping from 10 billion devices in 2020 all the way to 22 billion in just half a decade. That forces us to ask a pretty serious question. How on earth is such a massive, invisible global structure supported without the whole thing just completely crashing? Well, that brings us to part 2, the 5 pillars of connection, the true foundation of the network.
Because to support billions of devices, you have to pour a rock-solid foundation. Definitely mentally bookmark these 5 critical pillars. We're not just talking about slapping a Wi-Fi chip into a toaster here. These 5 distinct elements have to work together perfectly, seamlessly, to keep the entire ecosystem from collapsing. So how do they actually interact? Think of artificial intelligence as the brain of the operation, making autonomous decisions. Connectivity is the nervous system, allowing for seamless communication. The sensors, those are the eyes and ears, gathering precise data from the environment. Active engagement frameworks allow the system to actually interact with us. And finally, the hardware itself. These small, smart devices has to be incredibly compact and energy efficient so the network can be distributed literally everywhere.
Moving right along to part 3, the master architecture, and how we actually build these layers.
Now that we've got our core building materials, how do they actually stack up? Well, in the early days, developers used a basic 3-layer setup, just gathering data, sending it, and using it. And that seemed fine. But as this thing scaled globally, they had to evolve into a 5-layer model. They realized they needed dedicated data processing and business management layers. Because honestly, raw data without a solid business model to make sense of it is really just noise. If we literally step up the stack layer by layer, you can see exactly how this transformation happens. Down at the bottom, the perception layer is gathering raw physical data via sensors. It throws that data up to the network layer, which transmits it over Wi-Fi or 5G. Next, we hit middleware, which does all the heavy lifting with analytics. Then the application layer translates those analytics into smart interfaces we can actually use. And finally, sitting right at the very top, the business layer manages the overarching system. And this 3D structural blueprint is basically the backbone of every complex IoT system on Earth. You can trace that exact journey from a physical piece of hardware buzzing away down in the dirt at layer 1, all the way up to sophisticated, high-level business management at layer 5. Okay, let's shift gears to part 4, paradigms, everyday to extreme, where we map out the entire IoT universe. With that master architecture securely locked in, we can zoom way out. Because that exact same blueprint is applied across wildly different environments. We can divide this interconnected universe into 4 main areas: human and service, autonomous mobility, defense, and extreme frontiers. They all share those same 5 layers, but they are solving vastly different problems.
Starting with the societal side, there's a really stark contrast. On one hand, you've got the highly personal internet of people. Think of your smartwatch quietly syncing your health data to a digital profile. On the other hand, there's the highly mechanical internet of services. This is what unifies hardware and software to power factory sensing, and it's what lets companies beam over-the-air updates to products long after they've left the assembly line.
Now, taking this to the streets and the skies, we hit the paradigms of mobility. The Internet of Vehicles has the massive, constant headache of navigating physical motion, relying on these hyper-fast communication loops just to avoid pedestrians. Meanwhile, the Internet of Drones is staring down an incredibly steep regulatory mountain, trying to safely integrate fleets of unmanned drones into heavily restricted traditional air traffic control.
But what happens when we push this to the absolute limits? We're talking extreme frontiers where traditional infrastructure just completely fails. The Internet of Battlefield Things equips troops with real-time biometric sensors. The Internet of Space is literally bouncing signals off low-Earth orbit satellites to connect the most remote corners of the globe. And maybe the most mind-bending one, the Internet of Underwater Things uses ultra-small battery-powered sensor nodes to link submarines and the deep ocean floor right back to the surface web.
Finally, let's ground this in Part 5, Potential versus Friction, the reality of deployment.
Because before we get completely swept up in the sci-fi promises of deep sea and space tech, we really have to look at the real-world friction. Developers are walking a dangerous tightrope every single day. Pushing for that awesome real-time customer engagement? Well, that directly creates massive vulnerabilities in our security and privacy. The intense desire for tech optimization? That leads to extreme deployment complexity. It's a constant, endless game of give and take.
So scaling a network of this size ultimately demands some pretty ruthless compromise. You are constantly weighing these incredible benefits, like reduced waste and perfect data collection, against the heavy friction of ripping out old legacy systems, fighting off cyber attacks, and trying to navigate a maze of incredibly strict, ever-evolving global compliance laws.
Which leaves us with one final, kind of mind-bending question. In a universe where billions of autonomous devices are silently talking to each other right now, from the fridge in your kitchen to satellites in low Earth orbit, where exactly does the internet end and the physical world begin? Thanks so much for joining me for this explainer. I challenge you to look around your own home today and just consider how seamlessly this invisible blueprint is already woven into your life.